Great. Hi. Good morning. Good afternoon, and good evening to all of you. Greetings from Hanoi, Vietnam. What I wanted to do today is actually take a bit, perhaps a sort of less technical presentation, but a bit of an overview of how we've been using spatial data and big data to look at the waves of COVID across a number of countries in Asia. So, I mean, first of all, to think a bit about the COVID Observatory that we've set up, and using big data is really thinking about the extent to which we can actually use a number of the big data techniques, and I think particularly to get more spatially and temporally granularity insights for public action. So this could be informing safety net programs. It could also be a sort of understanding the linkages between some of the COVID. We've experienced different waves and lockdown policies and what's happening on the ground across a number of the countries, particularly the developing economies, where traditional statistical data can be quite scarce. So what you have here is basically sort of a model in which you can think about, and this model actually, we sort of sketched this out in March, right? And the idea was really that you have sort of these different waves of impact, and then the big data sort of mapped on them. You have the sort of emergency response to COVID, you have the recovery phase and the resilience phase. I think one observation in retrospect, of course, is that these waves have been far messier. I think in terms of the onsets of second or third waves and sort of, what the literature refers to as sort of deep V recoveries or squiggly recoveries. I think in retrospect, we're now seeing that the way we're using big data has been quite, has been through different types of waves. So the importance of having ongoing monitoring and understanding what the sort of temporal and spatial signal is from a lot of these non-traditional data sources is quite important. And I think with that, let me move, I think, to this rapid results, to using big data in a policy context and iterating fairly rapidly across these things. And I think one major observation I would make for many of you who are, I think, working with big data and others is that if you think about, I'm an economist, but I apply a lot of these techniques now. A lot of the data or the insights into COVID and others are really based on more traditional and familiar sources. So even the World Bank has a huge program now of using telephone surveys and business surveys and household surveys to capture the impact of things like COVID, and these are very familiar data sets. And I think what we're finding in a lot of this work is that you're sort of dealing with kind of two new factors and in this work. The first one is, of course, that you're having to link domain expertise from a number of folks who are often more comfortable or know how to collect data from more traditional survey sources to pick up sort of poverty impacts and socioeconomic impacts, and at the same time having to sort of combine them with a lot of the technical skills that I think many of the people in the audience today have: the data access, the engineering, the data science, the visualization. So I think the two key elements that we've been facing in this work have been the how and the so what, and then bringing together these two groups of domain specialists on the one hand, and the sort of technical engineering work that we have. And this, I think, requires, as much as the technical aspect of it, really the sort of agile, collaborative, and iterative teamwork. So what do I mean with that? And let me try to illustrate that very quickly with the Data Fusion expert. This is a screenshot from the Big Data Observatory, and what we really tried to do there is bring together a series of curated pipelines. In this case, it's about 12 pipelines that covered, and for communications and other purposes, 5 buckets of data. And they were human mobility data. Many of you are familiar in that, including some of the global sources, like the human mobility data, satellite data, the crowdsourced user data, transactions data, anything from procurement systems to more traditional systems, and text mining. So what I want to do now is I'll take you very quickly through some of the initial results, but given the really briefness of time, I won't spend too much on the technical deep dives, and I'm happy to follow up with folks afterwards on more of the technical deep dives and what we found in the different. But just to give you a flavor, and then I want to sort of come back to this issue of, how do you ultimately apply this data with some of your key audiences? And I think some of the takeaways for how we do better, and some of the process and the people issues that we really need to consider then. So I think what we turned into work is really to think about it as sort of an assets perspective and bringing in these different assets and mapping them. And noting that not every single data source or one data source is actually appropriate for tracking across time, say on a monthly basis, or across in East Asia, particularly, and other countries, the subnational dimension. So I'd sort of use the notion roulette wheel, not in the sort of game of chance, but just saying that you're really distributing your view of what's happening across these different data sources. So again, this requires, I think, a data science team that is actually able to work across both more traditional geospatial data like satellites and others, mobility data, but also some of the more traditional systems, and bringing that together. So let me illustrate an institutional context. And I think this is one of the important takeaways. Policymakers don't think in maps, or they don't think in satellite tiles. And this, just to give you an illustration of 3 countries that are covered by the Big Data Observatory. You have a diversity of countries like India of 1.3 million, Indonesia of 268 million, Vietnam of 95 million. But what I want to sort of turn your attention to, and a big focus, has been taking the big data and mapping it to actually the levels where decisions are made. And in the case of the work that we've done, it's really been about taking the subnational government angle and thinking about level 1, 2, and 3. Now, it is a generalizable problem, but you can very quickly, I think, see that there's a fair bit of diversity across how you map. So India, for example, the 28 states, the 103 subdivisions. So I think a lot of the work that we've been doing in terms of the big data is to try to sort of map these big data sources to that level of decision making and present the information in a way that then resonates, say, with mayors or governors, because I think that's a place where we're finding a lot of the frontline impacts or responses to the COVID. So now let me take you on a sort of very quick whirlwind tour just to give you a flavor of some of the signal that we were taking, and a lot of the effort to sort of understand the signal and noise from these different data sources and fusions, and then come back, I think, to the sort of people and process issues. So leading off with the mobility data, I think many of you, of course, are aware of data sources like the Facebook or the Google. What I show you here is really just trying to map the overlay and of policy stringency, and this is from the Oxford data set, which actually collects detailed information on the different policies at the national level that governments take, and then overlaying it with a set of mobility data that are coming from sources like Google, Facebook, airline data. We published a number of blogs and other things on that. But I think you can see here is sort of an attempt to visually intersect or understand the relationship over time between the policy stringency, which is the red lines, so the most extremes, of course, are the national lockdowns. But I think a sort of whole spectrum of policies, and trying to understand how do those actually play out over time across a number of the different settings, but also across space. And I think some of the takeaways that we've had is actually we found a fair bit of consistency, but it has taken sorting out, and particularly over spatial areas. So some of you may recall that recently Vietnam, after many months of having no COVID, suddenly had a resurgence of COVID in Da Nang, which is one of the tourism centers. So we were actually able to use a lot of this data and spatially show that there was actually a consistency in terms of what was happening on the ground. But a lot of the work was trying to sort of triangulate and see whether the big data was actually consistent with the policy stance, but also a number of the other sources. And I think this then takes me to the satellite data. And here we've been using particularly the data on the night lights and the NO2. And the challenge here from a data analytics point really has been about how do you square the sort of the satellite data and how our remote sensing folks are comfortable in terms of the annual up to the daily resolutions of some of the satellite data, moving from spatial granularities that are anywhere from a kilometer, a half a kilometer, to sort of 0.3 meters, and addressing a lot of the issues. So a lot of the work, I think, has been about getting more confidence with more mainstream audiences that are not used to so much using the satellite data, and presenting it in a way that again maps back to these, I would call governance dimensions or governance areas. So we put in place, and happy offline in the chat to get people working with partners, New Life Technology and Space for Good, put in 2 standalone resources that are actually designed to map these near real-time insights to subnational dimensions, and then provide perhaps non-specialist users with a lot of the supplementary information, such as cloud covers and others, that begin working with them so that they can actually interpret this signal. So a lot of it has been about bringing a lot of this big data closer to the users, but customizing for these access. Here again, I think I was giving you the discussion about Vietnam, and this is really then beginning to present where the different shocks seem to be concentrated. I think consistent with some of the stories that COVID has in many cases had a strong impact in terms of particularly the socioeconomic activity in urban areas, and then you have to look at sort of fairly mixed pictures across. But again, I think the key point has been working with a lot of the domain specialists to understand, is this consistent with their priors and their more traditional data sets, especially as you're moving into a space where the temporal and the spatial granularity is a lot higher, and what they're really expecting from the big data is a more near real-time picture of what's going on. I think on the crowdsourced user data, I'm going to move very quickly now since I think I have 3 minutes left, is working with sources like Premise, which is a sort of a group from San Francisco that does sort of paid recruiting on Facebook, but then sets up a number of these custom and ongoing surveys. So here's an example from the Premise work, doing these sort of custom and bespoke surveys, which we would sort of call directed crowdsourcing, which were then again overlaid with a lot of the other data early on, the mobility and the other data that I was showing you. On the transactions data, we were mainly focused on public sector data like procurement data. And what you see here is, data from a global system that the World Bank maintains on procurements and procurement implementation. So this is only a subset of basically a fairly significant subset of procurements that are done, that are financed by the World Bank. And what we looked at is, did COVID have a systematic impact over time in terms of delaying both the commitments that were made in terms of procurement, but actually implementation of procurement. And I think then doing the analysis and trying to understand, are you getting a whole new wave of procurements coming on stream? For example, procurements around major, what we're now seeing, getting ready for vaccinations or emergency personal safety equipment. But then what's happening to other areas like the traditional infrastructure and others? So this is sort of part of the analysis that was done in terms of bringing this data. But again, very different structured data than the satellite data was, but making the point that you do need a fairly diverse team that can allow you to sort of work with the administrative data, and I think finally the text mining data, and beginning to see if the signal is consistent. So the policy stringency data that I showed you earlier from Oxford is a sort of more traditional compilation of what were the actions that the government was taking, and then overlaying that. But here with the text mining, what you then begin to see is beginning to sort of break these government measures down into more refined areas to try to understand, is there more granularity, and what are we seeing in the patterns for the satellite data and mobility data both across countries, but most importantly to try to decompose that to the subnational level. So a lot of the text mining work has been directed at getting that spatial dimension and teasing it out. So sort of to bring it together, and in the last 2 minutes, just to give you a sense of what we've done, the Vietnam COVID Observatory, happy to then share links. This is sort of a work in progress, but I think a view of how you try to pull some of this together, brings these data sources together, tries to structure it around a set of data stories that I would say try to pick up on the strengths and weaknesses, the signal and the noise of each of the individual data sets, but then increasingly also starts to work to do some of the data fusions to look at the consistency and the coherence between the data. So, examples, most of our work now has been looking at, for example, how does the night lights and the NO2 data from the 2 data sources that I showed you appear to work across a number of countries in the region, East Asia and India, with the signal that we're getting from the more detailed Facebook, Mapbox and other data, as well as some country level data such as very detailed and very large data sets on tracking vehicles in countries like Vietnam and others. Of course, some countries have been using cell phone data. So I think to conclude, what I've given you is a sort of very rapid view of bringing together what I think you shouldn't forget for many analysts and socioeconomic data folks who work on this area and the domain specialists is still relatively new data. So while many of you are, I think, quite comfortable and in the practice of working with geospatial data, of working with big data, of doing these, for many of the audiences, it's still a relatively new area. So I would say that there's sort of 4 A's that kind of emerge as important, both from the COVID, but in terms of bringing together this type of work. The first is really revolutionizing or rethinking the way access to data is set up. The bank, of course, has a data collaborative with a number of the large data providers, but also with a number of other partners at the national level. But it's really about thinking about different ways of accessing data rather than the traditional model, which is you download a data set, even in the more academic data setting, you work with it, you write your report, is really thinking about a more of a sense of these sort of standing pipelines of data and APIs. And I think this is what we've tried to do with this work in the setting. So all of the examples that I've shown you really have been also about setting up APIs and then continuous processing that update at least on a monthly basis. A lot of work goes into the analytics of signal and noise, which I'm going to say, and then signal really is the analysis of the big data actually telling you something that is consistent with priors, or at least with some of the other data, or is it at least being triangulated on the temporal and the spatial side? And when I say temporal, I really mean that you're moving from a frequency of more traditional data that gives you insights in a survey for, say, every couple of months, or every for more traditional GDP data every quarter or so, to monthly or quarterly or even daily temporal resolution and then spatial resolution. I think I put a lot of emphasis in this talk on mapping it to these governance dimensions in the different countries. So just put yourself in the shoe of the country that you're in at the moment and think about what are those governance levels where you would need to map the spatial data to, and then communicate that to your colleagues and counterparts, and how do you present that? The third dimension has really been about the application of demonstrations. So are you using this to tell somebody what's happening in between 6 months where they don't have GDP data and you're giving them information? Or are you using it, for example, to evaluate the efficacy of a policy lockdown in terms of actual people behavior? So I think bringing out the relevance of this data has been sort of an important part of it, and happy to in the question and answer. And I think the final point, I think this is really for us in terms of colleagues and counterparts, is the adoption. And there, I think for us and the World Bank and this type of work has been the adoption, including in the more traditional settings of statistical agencies, ministries of finance and planning, is getting people after the COVID crisis to actually see the value of this type of data and mainstream it more, similar to a lot of the colleagues. So the COVID has not, I think, been both an opportunity to showcase some of the value of this sort of big data, high temporal and spatial granularity data, but increasingly beginning to think about how can we mainstream this work more in terms of the access, the analytics, and the applications in day-to-day work. So final concluding slide, I think, is sort of really the 3 big so whats. People talk a lot about big data and the promise and how we need to have this thing, but I think I would leave you with sort of 3 points from this work. The first is, I think, thinking very hard and getting the right mix of domain specialists and technical specialists on addressing the signal to noise point, because you do get a lot of noise even on the data, and working with that is as much as art and a science. And I think that skill of being able to bring out both the temporal and the spatial is super important. The triangulation. So I've mentioned to you that most people in the socioeconomic field are more comfortable, I would say, still working with more traditional structured data, household survey, GDP data. So how do you triangulate both across these big data sources and the emerging data sources? So how do you work in terms of actually showing the relationship, say, between a GDP series and some of the say geospatial nightlights data and others? While there's a lot of literature when you actually try to do this in a recurrent policy environment, I think it's still somewhat of a new art. And finally, I think this point about the sustainability. How do you put this data from beyond an academic study and the type of study that we can present in fora like this to frontline user-centric value. And I would hope and suggest I'll turn you to the platforms that we've set up. But I think really thinking about increasingly presenting some of this curated data in a way that non-technical specialists can actually use. So I think the examples that I've given you in terms of the nightlights data and the NO2 is thinking that even a mayor might be able to look at the NO2 in his or her domain or the nightlights data and bring some interpretation, in addition to, of course, getting some of the key statistical data or the big data that a more savvy and seasoned analyst would use. So let me kind of stop there and take some questions from the backstage.
Sure, Kai. One question that we have from Twitter was about skill sets. So what kind of skill sets are you recruiting, or do you have in a team like the one who work on these types of projects?
Yeah, so it's a good question, right? Because you have a project like this where you require a lot of the sort of the data skills, across spatial data, textual data, and others. So you have sort of the data scientists. So frankly, a lot of the skills that we've recruited, and again, I mean, I make a deeper point about an organization, even like the World Bank and others, where the profile of hiring a data science is still sort of an emerging field, right? So you don't have a lot of people who come from a data science background. Still, people are trained really as economists or social specialists. So a lot of the folks that we bring in are actually sort of data scientists and consultants. And I've found that it's been sort of a mix of skills in terms of really getting these multi-sectoral teams to work on both the data science skills, the ability to set up the notebooks, to do the work and interrogate the data. I would actually, I mean, I think the point that I would really say to people is, obviously the people that we are trying to recruit are both people who have strong analytical skills, but who are really able to work with the domain specialists really in this agile and iterative way, right? So that they're able to listen to the domain specialists, to kind of get into their minds and then work back to the analytics and iterate and bring that skill to that. So I would say beyond the skills in each of the types of data that I've shown you, it's really this ability to listen to the domain specialists, iterate fairly quickly. And I know for a lot of the data scientists that can sometimes be a bit frustrating, right? Because it's sort of a longer conversation. But it's how do you create that team dynamic to query the data? And when you have something like COVID, things move pretty quickly, and you think that you're looking at a structured phenomenon, but you're actually looking at a phenomenon where things can move in very, very different ways in different directions. So I think the adaptability and the agility on that skill set would be key. So what we look for, I think, are obviously typically people with with at least a master's or a PhD, ideally who have had some seasonality. We bring them in typically now as consultants, but one of the key abilities is really to work with what I could say the more traditional domain specialists, right? And listen to them and understand and do a lot of explanations for them, right? In terms of what this data is and what it's saying.
Fantastic. Okay, great. I think we've got time to squeeze in one last question from the chat, which is Raffaele Pranzo, who's asked, can you give some examples of the type of noise you had to deal with during your analysis on Vietnam?
Sure. So let me give you two examples. One example from Vietnam and another one from Timor-Leste, which is in Vietnam, one of the issues of nightlights, for example, it's a sort of general proxy, it's accepted in the literature. So it turns out that in Vietnam, and you would think that, with nightlights and what you see in China, that the nightlights would pretty clearly pick up even at the subnational levels what's happening. Now, it turns out, for example, in Vietnam, you have something called dragon fruit plantations. These are large, I don't know if any of you have eaten dragon fruit, but it's sort of this sort of exotic food, I guess, that you would find in Whole Foods or something like that. But it turns out that you have the dragon fruit plantations use lights very strongly, nighttime lights to illuminate the crops. So you actually find a huge lot of noise from these dragon fruit. So you have to sort of filter these dragon fruit out because they're really very different than what you're trying to pick up through the socioeconomic activity. So that's one example of noise, and then you have to find ways in which you filter that noise out in a more regular way by adding screens and masks to filter out that type of noise. Second example that, we're dealing with at the moment, and I think this is sort of, an example from some of the Pacific states, is, finding a lack of consistency, for example, where the policy lockdown or the stringency happened in March and April, and you're finding that the night lights actually surge quite significantly in the month after that. So your results on the night lights seem to be suggesting that the month after you had the lockdown, that everything goes up, but then you have to do very, very deep analysis of the cloud cover, the temporal, and some of the topographical areas to actually be able to squeeze that out. So I think that's one buckets of noise. So the consistency with that on the night lights. And then let me give you the second example of noise, which is one of the popular data sets that's of course being used now has been the sort of Facebook data, through the data collaboratives, where you get mobility data in Bing tiles and you map it to particular areas. Is you have to start thinking about the noise that you get when you fall below a certain signal level. So the platforms that we have, cover anything from very dense urban areas and very, dense Facebook user areas, say in Vietnam, of Ho Chi Minh City and others, where you have a very strong density of Facebook users and you can kind of at least get the signal. And versus if you start using the data in some places in the Pacific, or even in some of the rural areas, your signal becomes very thin. So you have to be doing a lot of the analysis to sort of understand what is actually your sample depth, and understanding that you're not getting spurious. So that's, I would say, a second very practical example of noise that you need to deal with. So you need to think creatively, how do you benchmark that sample size, and basically begin to understand, are you actually getting signal? So if you think back at the map that I showed you very quickly, right, you're not only sort of picking up dimensions in urban areas because you think that they might be hit particularly strong due to COVID, but you're also having to think about the rural areas. How much signal do you actually have? And when you're picking things up in the rural areas, is it just because you have a lot less signal and users, not signal, but a lot less observations relative to population because of face user penetration among the poor and others, then you do that. So that would be a second sort of example of the types of issues but happy to talk offline, because this noise and signal issue has been, I think, something that we've had to tackle actually in fairly creative ways, right? You look at the literature, but at the end of the day, if you're working on a more real-time policy basis, you have to be doing it in a kind of an ongoing, as much art and science way. And again, I'm back to the skill set. I think that's one skill set that we look for with people is, data analysts who are really creative and who really then try to sort of tease out that signal, right? So they have to pursue it like with a sort of passion, that they really come back and say, I really want to, I want to try to understand what's going on here. So I would say that's actually one of the most important soft skills, in addition to being able to work with the domain specialists.
Brilliant. Well, thank you very much, Kai, for joining us. I think that's all we've got time for today. If anybody wants to carry on the conversation with Kai on the chat, feel free to do so, or in the Slack community. But for now, we'll say goodbye to Kai.
Great. Have a good one.